Hey guys, this is Madhushantan, currently working as an applied AI engineer at Maxim. Maxim is an AI evaluation and observability platform where you can test your AI agents or workflows, making them more reliable, ready for production grade. So this is one of my first videos in the brand new video series that we are starting out, where we go through these AI research papers, break them down and explaining them in simple concepts so that it's easier for you guys to understand them and apply them. So today we're going through this paper called OdysseyBench, where they evaluate LLM agents on long horizon complex workflows, something that us humans would do in our everyday jobs. And these guys focused particularly on the office application workflows. So just to give you some context, if you were to consider the last 6 months and see how AI is rapidly evolving, there's always this constant debate and discussion whether AI would automate real world workflows, something that us humans would do in our jobs. Now, if I were to tell you, these models are at a very early stage of automating our real world user scenarios completely. Don't get me wrong, these models are very good at a lot of things like software development, programming, scientific research, and a lot of other things. But it's just that there's a subtle difference between what these models are exactly doing and what we humans do in our everyday daily life. These models are very good at doing these atomic tasks, which is essentially a question and answering turn, which doesn't require previous conversation. But these complex workflows require the agent to go back to look at its conversation, get relevant information from there, and apply right here to do a particular action. Just to give a graphical representation of the difference between the atomic tasks and long horizontal tasks, it's just these questions and then answering without any prior context. But if you look at this particular task, which is a complex task where the agent is required to go through its previous conversation, get relevant info, and then even though there are chit chat events in the middle which are irrelevant, it has to accurately get the necessary information and use it and apply it in its present action, which is something a human would do. Now let's go through the contributions of what these guys have done through their paper. It's primarily this OdysseyBench, which is split into two components, which is OdysseyBench Plus and this OdysseyBench Neo. OdysseyBench Plus consists of 300 long horizon tasks which replicate these office scenarios, which is predominantly built from its predecessor called OfficeBench. Now, OdysseyBench Neo consists of 302 newly generated tasks, completely built by AI, which is completely scalable, where it's the tasks and the dialogues are a little complex, where the agent is required to go through its previous conversations, reason about them, get the relevant information, and maintain all of that context to do a particular task. Now they've also mentioned the frameworks, multi-agent frameworks that they've used to build these benchmarks. It's Homer Agents Plus, and there's Homer Agents Neo. Now, Homer Agents Plus is a simple two-agent framework that runs in a loop, which consists of a verifier and a dialog generator. The dialog generator generally has context of the task descriptions and provides the task intent and along with the dialogues to the verifier, to which the verifier, given a particular criteria, it says if it's okay, or if the quality is not up there, it will give feedback back to the dialogue agent, and then it's a iterative constant feedback loop until the dialogues are pretty good enough. Now here's the graphical representation of the Homer Agents Plus, on which they've built OdysseyBench Plus. Here's the dialog generator, and here's the verifier. And if you were to consider Homer Agents Neo, this is actually a multi-agent framework built on a existing framework called Magentic 1 framework, where it's a domain agnostic framework that's released way back in 2024, and these guys have particularly used it for these office application scenarios. Now, let me just go through this particular framework once. There's an orchestrator at the start, so the whole thing is an environment, and there are a lot of applications provided. Let that be Microsoft Excel, Word, PDF, and a lot of other applications. So the orchestrator plans gives multiple plans across 3 to 4 phases, where it mentions what the surfers should do, plan for the task generator what it should exactly do, and the plan for the dialog generator what it is ideally should be able to do. Now, these surfers, given the plan from the orchestrator, go through these multiple applications and give back some context and contextual information, which is given to the task generator. This is essentially required so that the dialogues generator are grounded to the real world scenarios. Now, the task generator, with the help of the plan of the orchestrator along with the context, generates the subtasks and the task description and also the task intent along with the evaluation criteria of that particular task. This is the major step of this whole Homer agents Neo. And given the task intent, description, and also the plan, the dialogue generator is responsible for actually generating the dialogues across a particular session. It's just user and assistant dialogue interactions that you would see in an object. Now, this is the algorithm for exactly what I've told. And if you see, all of the phases are written down here. The dialogue generator provides a comprehensive dialogue history, where it's an object of all the dialogues in here. Now they've specifically used GPT 4.1 model for all of their agents, considering its trade-off for cost and efficiency. And regarding the other implementation details, if you were to go down, they specifically did not actually do the during their benchmark process. I mean, the dataset creation process, they've made sure that the agents did not actually did the actual execution of the task, but simulated the whole conversation, because essentially that's exactly what they need to do the whole thing. But yeah, that's the methodology of and the difference between these two particular frameworks. And if I were to tell you the major difference between these two frameworks is that the task descriptions are actually gotten from its predecessor OdysseyBench. Here the task descriptions are completely written down from scratch through the whole process, where the task generator actually does it. Here it's just gotten from an existing benchmark. Now, this is the framework where they've done it. They've used the GPT 4.1 model, and all of this benchmark is constructed in a Docker environment containing pre-installed applications, as we have talked. Now, yeah, so the major metric they've considered is the pass rate, which is basically the total successful tasks by the total number of tasks. Now, regarding the dataset analysis, TLDR, so basically, if you were to see this particular data statistics in this particular table, think of a session as something that of all the conversations in a particular day would be a single session. So if you were to see 27.9 is the average session, it would basically mean 27.9 days of conversation, which would go as context to the agent. And utterance, if I were utterance is basically all of the user assistant interactions in a particular session. So the major difference between these two splits of the benchmarks is that the average session is 27.9, and they specifically put it down to 5 sessions only for AgentBench Neo, but the utterance is 7x to that of the OdysseyBench Plus. The average is around 11.4 here, but here the utterance is 73.2, where the whole conversation has a lot of complex interactions between the user and the assistant. And of course, it actually takes in more tokens, even though it's just 5 sessions of conversations. That's the major difference between these two. And they have done some quality checks where they've checked if the evaluation criteria given by the task generator is under the predefined evaluation function library that they've given. And they've also, another test that they've done is that given the task intent in one scenario and given the task description in another scenario, they've used O3 model to see if O3 is able to complete that particular task in either one of those scenarios, task intent or task description. And they've only considered those particular tasks where O3 was able to do it, both of them, making sure the quality is there and the all of the samples, all of the task intents in the description in the particular benchmark are grounded. And they've also had a few people, a few humans to actually do the whole human agents neo to see the performance of humans, and it sits right at 91.43 overall. Let's see how the models did it. But let's go through the experiment setup once. This long context evaluation, where you give all the previous conversations as dialogues as raw text directly to the agent in its conversation history through prompting in its prompt. And there's RAG evaluation. So there's two things in this RAG evaluation: there's raw context and this summarized context. Considering raw context, there's actually session level and utterance level. So what you do in this RAG evaluation, what they did in this RAG evaluation process is that they took the entire dialogue of each session and embedded the whole thing into a single document. The whole session is embedded into a single document, and at the utterance level, they've taken each turn, a user and assistant turn, and embedded that into a single document. So we would have multiple documents of all the embedding of all the turns. And then there's summarized context. Under summarized context, there's actually session level and chunk level. Session level basically is that the whole session is summarized and then it's stored in a single document. And when you look at the chunk level, multiple sessions are concatenated, joined together, and they're segmented into multiple chunks, and each chunk is summarized and put it into its respective document independently. Now, this is the setup. This is just the long context and the raw evaluation that we will be going through. And there's also the evaluation metric is the pass rate, exactly what we've discussed. And the models are, there are multiple models from OpenAI, including their top reasoning model O3 and also the newly released GPT-5. And there's also the three open weight models that they've used. So this is the final benchmark of how the models performed, and these are the other results of how they did across the dialogue storage, if that's long context direct prompting or it's summarized or embedding way. But we'll go through them. So if you look at the results, the four major things, the four major points that we get out of all the experiment is that tasks get increasingly complex with more applications involved, leading to a performance drop. If you look at this particular table where it's increasing, the number of applications are increasing from 1 to 2 to 3, the pass rate is actually decreasing, and this is the same and consistent, where the decrease is consistent for all of them, including OdysseyBench Plus and Bench Neo. The other thing is that more context typically leads to better performance, but there's a catch here. If you look at right here, the top K essentially means the top K retrieved documents that you would give as context to the model. If the top K is 50, which is the highest in here, the overall pass rate is the highest in here, considering the long context utterance things. And if you just see in the raw context of raw, if you were to give the whole conversation as in the prompts, it's actually the highest, 33.67. And you can actually see the same happens for OdysseyBench Neo 2, where it's the highest, 38.74. More context, better performance. But and also you can actually see that in one application and the three application space, it's actually performing better than the long context one. It's 57 here and it's 47, and it's 17 here and 15. But it's not the same case with OdysseyBench, where the pass rates are not actually more than the long context one. And the reason for this could be excessive fragmentation of information might undermine the context integrity. Now the other point is that summary storage effectively captures task essence. So in these tables, if you were to consider the storage as where you summarize the whole session, or the summarize those chunks of concatenated sessions, you can actually see there's an increase in the task rate pass rate, which is 53.64 here, and it's 56.29 here, which is way more than the long context bit with using a lot less tokens, which is way more efficient. So TLDR, aggregating information across multiple documents, is actually a good sign. I mean, good thing to do, where you don't really take in the irrelevant information that's unnecessary in cases like this. And they've also analyzed the failure cases of where of what exactly happened. Most of it is, it's just agent missing the required files, doing incorrect tool calls, inaccurate planning and stuff. And the one last thing that they've observed is that retrieval volume actually diminishes the results. And if you were to see, ideally more context actually increases the pass rate, right? But in this particular case with OdysseyBench Neo, when they've increased the top k to 50, they've actually observed that the pass rate actually decreased a bit. And this can be justified with the hypothesis that long contexts introduce more noise and irrelevant information, making it hallucinate, and not the model has a lot of noise in its context. So yeah, that's about the whole paper. TLDR models are not really at that particular stage where they're very good at doing real world tasks, user workflows, particularly the office workflows. And but this particular agent framework that we have talked about, Homer agents, is a very good uh, learning that one we can use, where we can use it in building a lot of other benchmarks and a lot of other scenarios. Yeah. And one more important insight is that even with RAG, right, even if you were to have a lot of documents, like 50 to 60 documents, it's better to summarize them, each document, and put them and embed those summaries and use them as context, instead of having more all the 50 documents just as is as context to the agent, which might which might increase a lot of noise. So yeah, that's about the paper. uh, Thank you for listening. And also there are additional prompts, of exact prompts of what they've used in their whole verifier agent, generator agent, which you can go through in this particular paper. We'll link this paper down below. Yeah, thanks, have a great day.